Chapter 1. The River of Milk. In the depths of a warm summer night, when the air grows still and the world seems to pause, look up. Above you stretches a luminous river across the darkness, a band of light so delicate it appears painted by some cosmic hand. The ancient Greeks believed they saw spilled milk flowing across the heavens, a divine accident frozen in time. The Romans called it the Via Galactica, the road made of milk. For thousands of years, humanity gazed at this celestial ribbon without understanding its true nature. But what appears as a milky streak is something far more extraordinary. You are looking at your home from the inside, a vast island of stars, gas, and dust spinning through the cosmic ocean. This is the Milky Way galaxy, and you are part of it. Imagine, for a moment, that you could step outside our galaxy and view it from a distance of several million light years. What would you see? A magnificent spiral, like a cosmic whirlpool frozen in a moment of perfect grace. The galaxy would appear as a large pinwheel rotating in space, with stars, dust, and gas fanning out from the center in long spiraling arms. NASA. At its heart, a bright bulge glows golden red with ancient stars. Extending from this center, elegant spiral arms sweep outward, traced by brilliant blue-white stars, the young giants that illuminate the darkness. The Milky Way stretches approximately 100,000 light-years across NASA, though recent discoveries suggest it may reach even farther. To cross from one edge to the other, traveling at the speed of light, the fastest thing in the universe, would take you 100,000 years. Within this vast disk dwell somewhere between 100 and 400 billion stars, each one a sun, many hosting their own families of planets. Our solar system resides in a quieter neighborhood, about 26,000 light-years from the galactic center NASA, nestled within a minor arm called the Orion Spur. Here, far from the crowded inner regions, we orbit the heart of the galaxy in a stately cosmic dance. It takes our Sun, and Earth with it, 250 million years to complete one revolution around the galactic center NASA. The last time we were at this position in our orbit, dinosaurs had not yet walked the Earth. We are voyagers on a journey that spans deep time. The Milky Way's shape, that distinctive spiral, is no accident of nature. It represents billions of years of evolution, countless collisions, and the patient work of gravity sculpting matter into beauty. But to understand how this galaxy came to be, we must travel back in time, back to an era when the universe itself was young and the Milky Way had not yet learned its own name. Chapter 2. Birth and Chaos. Nearly 14 billion years ago, in the aftermath of the Big Bang, the universe was a cauldron of primordial gas. Clouds of hydrogen and helium, the only elements forged in that first cosmic fire, drifted through the darkness, gradually pulled together by gravity's patient hand. Our galaxy began to form approximately 14 billion years ago. NASA. In the beginning, it was not the elegant spiral we know today, but something far more chaotic. The galaxy emerged from enormous clouds of gas and dust that coalesced under the force of gravity. Quantum magazine. Imagine nebulous blobs swirling together, colliding, merging, a cosmic storm of creation. The first stars ignited within these clouds while the proto-galaxy was still roughly spherical. These ancient suns, born when the universe was less than 1 billion years old, still drift around the Milky Way today, relics from another age. They form what astronomers call the stellar halo, a vast spherical envelope that completely surrounds the disk and central bulge. Wikipedia. These elders have witnessed the entire history of our galaxy. Research indicates that the galaxy's old thick disk started forming approximately 13 billion years ago, only 800 million years after the Big Bang. Nature. This thick disk, a pancake of stars about 6,000 light-years in height, represents the Milky Way's adolescence, a time when star formation blazed at a fever pitch. But the young galaxy's development was not smooth. Far from it. Our galaxy grew through violence. Ancient stars in the Milky Way's disk were stellar immigrants, born in other clouds and dwarf galaxies that slammed into the forming Milky Way. Quantum magazine. Small galaxies, drawn by gravity's inexorable pull, plunged into our growing cosmic home, their stars scattered and absorbed. This was not destruction. This was construction, the universe's way of building something greater from smaller pieces. The most dramatic of these encounters happened 11 billion years ago. A dwarf galaxy astronomers now call Gaia Enceladus/Sausage merged with the Milky Way science news. This collision was catastrophic and transformative. The merger triggered so many new stars that the galaxy's star formation rate reached a record high science news. The intruder's gas crashed into the Milky Way's own clouds, and in those violent compressions, stellar nurseries ignited across the galaxy. The night sky of 11 billion years ago would have been dazzling beyond imagination, filled with the blue-white brilliance of newborn giants. The collision also flung stars from the Milky Way's disk upward into the halo. Splash, stars that bear the chemical signatures of the thick disk but orbit in the spherical halo science news. These refugees still tell the story of that ancient cataclysm. Chapter 3: The Age of Transformation. After the Great Merger, the Milky Way entered a new phase of its existence. The thick disk exhausted its gas supply 8 billion years ago and ceased producing stars science news. The galaxy's turbulent youth was ending. The frenzied star formation that had blazed for billions of years began to subside. But something remarkable happened during this transition. Fresh gas from the surrounding space, perhaps from smaller satellite galaxies, began settling around the Milky Way. This new material didn't simply add to the thick disk. Instead, it formed something different. A thinner, more refined disk, only about 1,000 light-years thick at the spiral arms Wikipedia, layered within the older, thicker structure like a record nestled inside its sleeve. This thin disk became the birthplace of new generations of stars, including our own sun, which formed 4.6 billion years ago. Astronomy.com from a cloud of gas and dust that had been enriched by previous stellar generations. Every atom in your body heavier than hydrogen, the carbon in your cells, the oxygen you breathe, the iron in your blood, was forged in stars that lived and died before the sun was born. As the thin disk took shape, something else emerged: spiral structure. Observations of distant young galaxies show they had bright, clumpy star-forming regions, but no regular spiral structure in their infancy press books. Bright, well-defined spiral arms began appearing only when galaxies were about 3.6 billion years old, initially with two-arms press books. Multi-arm structures like we see in the Milky Way appeared only when the universe was about 8 billion years old. Press books. The formation of spiral arms remains one of astronomy's beautiful mysteries. How do these structures arise and persist? Two main theories explain their origin: density wave theory and stochastic self-propagating star formation. Wikipedia. In density wave theory, gravitational interactions create waves of higher density that sweep around the galaxy like ripples on a pond. Stars and gas pass through these density waves, and when gas clouds enter these regions of compression, they collapse to form new stars. The alternative view suggests spiral arms form more organically. When massive stars are born, they live fast and die young, exploding as supernovae. These explosions generate shockwaves in the surrounding gas, facilitating the spread of star formation. Wikipedia. New stars form in chains and arcs, creating short-lived but brilliant spiral features that come and go. The reality may be a combination of both processes, the galaxy employing multiple methods to paint its spiral portrait. Chapter 4: Anatomy of a Galaxy. To truly know the Milky Way, we must understand its architecture, the components that give our galaxy its character and complexity. At the very heart lies something both invisible and inescapable: Sagittarius A*, a supermassive black hole with a mass of approximately 4.3 million times that of our Sun. Wikipedia. This cosmic giant sits in the constellation Sagittarius, exactly where ancient astronomers noticed a peculiar radio signal emanating from the galactic core. For decades, astronomers suspected a black hole lurked there, but proof required watching the motions of stars near the center. They tracked individual stars orbiting the invisible monster, their paths governed by its immense gravity. In 2008, Reinhard Genzel and Andrea Ghez determined Sagittarius A*, mass through these stellar orbits. Wikipedia, work that later earned them the Nobel Prize. Then, in May 2022, came the ultimate confirmation. The Event Horizon Telescope collaboration released the first image of Sagittarius A*, showing its shadow surrounded by a bright ring of glowing matter. Event Horizon Telescope. Despite its tremendous mass, Sagittarius A* is remarkably quiet. The black hole has not been actively consuming material around it. NASA. But it wasn't always so dormant. Evidence suggests the sleeping giant woke approximately 200 years ago to devour gas within its reach before falling silent again. NASA. That brief feeding frenzy created X-ray echoes still bouncing off nearby gas clouds, ghostly reflections of an ancient feast. Surrounding the black hole, the central bulge swells outward, dense with billions of older stars that glow golden and red. From this bulge extends a structure that shapes the entire inner galaxy, a bar of stars stretching across the core. The Milky Way is a barred spiral galaxy. Wikipedia, and this bar plays a crucial role in channeling gas inward and organizing the spiral arms that spring from its ends. The spiral arms themselves remain somewhat enigmatic. The Milky Way's spiral structure is uncertain, with no current consensus on its exact nature. Wikipedia. Observations suggest there are at least two major arms, the Scutum Centaurus and Perseus arms. NASA science, along with several minor arms and short spurs. Chapter 5. The Spiral Gardens. The spiral arms are where the galaxy truly comes alive. These regions contain a higher density of interstellar gas and dust than the galactic average, along with a greater concentration of star formation. Wikipedia. Think of them as cosmic gardens where new stars bloom. Travel into a spiral arm, and you would find yourself in a region of stunning celestial architecture. Giant molecular clouds, the birthplaces of massive stars, delineate the bright spiral arms. Astronomy and astrophysics. These clouds, vast beyond comprehension, are cold and dark, but within them, gravity works its ancient magic. Where the gas grows dense enough, it collapses and nuclear fusion ignites. A new star is born. The young, massive stars born in these stellar nurseries burn brilliant blue-white, thousands of times brighter than our sun. They live fast, sometimes only a few million years, but in that brief time, they illuminate the spiral arms, making them visible across intergalactic space. When these giants exhaust their fuel, they die spectacularly, exploding as supernovae that seed the galaxy with heavy elements and trigger new waves of star formation. Astronomers have discovered that the spiral arms aren't perfectly smooth, but contain structures jutting out at dramatic angles. Spurs or feathers. NASA Jet Propulsion Laboratory that hint at the complexity of galactic dynamics. Our solar system resides in one such feature, a structure within the Sagittarius arm that pokes out at nearly 60 degrees. NASA Jet Propulsion Laboratory, far steeper than the arm's usual pitch angle of about 12 degrees. This region contains some of the sky's most magnificent sights. The Eagle Nebula with its famous pillars of creation, the Omega Nebula, the Trifid Nebula, and the Lagoon Nebula. NASA Jet Propulsion Laboratory, each a stellar nursery where infant stars emerge from cocoons of gas and dust. Recent measurements have revealed that the local arm, once thought to be merely a minor spur, is actually quite substantial, stretching for more than 20,000 light-years. Science. Its density of star-forming regions is comparable to the major arms. This discovery challenges our understanding of spiral structure and suggests the Milky Way doesn't have a pure grand design pattern, but something more complex and organic. Science. The spiral arms rotate, but not as a solid wheel. The galaxy exhibits differential rotation, with material closer to the center completing its orbit more quickly than material farther out. Lumen learning. This differential motion constantly reshapes the spiral pattern, stretching and reforming the arms in an eternal dance of matter and gravity. Chapter 6. The Quiet Years. For the past 8 billion years, the Milky Way has known relative peace. The Milky Way has been quite quiet for the last 8 billion years, experiencing no encounters with other large galaxies. Science news. This tranquility has allowed the thin disk to form and mature, creating the conditions necessary for planets, and perhaps life, to flourish. The lack of recent major mergers is unusual among similar spiral galaxies. Wikipedia. While our neighboring Andromeda galaxy has experienced more dramatic collisions in its recent past, the Milky Way has spent its middle age in comparative solitude, slowly converting gas into stars in a measured, sustainable way. But the galaxy is not entirely inactive. Star formation continues, especially in the disk's spiral arms. Wikipedia, though at a more sedate pace than in the galaxy's youth. The Milky Way produces new stars at a rate of about 1 to 2 solar masses per year, modest compared to some galaxies, but enough to keep the spiral arms bright with young, hot stars. The halo surrounding the disk continues to capture and consume small satellite galaxies. These minor mergers are gentler than the cataclysms of the past, but still add to the Milky Way's mass and complexity. The Sagittarius dwarf elliptical galaxy, for example, is currently being torn apart and absorbed, its stars streaming out in long ribbons around our galaxy. Dark matter, that mysterious substance that neither emits nor absorbs light, pervades the entire system. The vast bulk of the halo consists of dark matter, material of unknown composition that cannot be seen, but whose presence is deduced by its gravitational effects. Caltech. This invisible scaffold holds the galaxy together, its gravity binding the visible matter we see. Without dark matter, the Milky Way would fly apart, unable to maintain its coherent structure. The galaxy we inhabit today is mature, stable, and by cosmic standards, peaceful. It has grown from chaos to order, from a cloud of primordial gas to a magnificent spiral spanning 100,000 light-years. It has weathered collisions, consumed smaller galaxies, and forged generations of stars. In its disk, on an unremarkable planet orbiting an average star, life emerged and eventually gave rise to beings capable of looking up and wondering about their place in this vast cosmic river. But nothing in the universe is truly permanent. The Milky Way story is far from over. Chapter 7: The Approaching Dance. About 2.5 million light-years away, another spiral galaxy glides through the cosmic dark. Andromeda, also known as M31, is the Milky Way's nearest large galactic neighbor, visible to the naked eye as a faint smudge in the autumn sky. It is magnificent, containing about 1 trillion stars, roughly 3 times more than our galaxy. And it is coming toward us. Andromeda is approaching the Milky Way at approximately 110 kilometers per second, as indicated by observations showing its light is blue-shifted. Wikipedia, compressed by the galaxy's motion toward us. This might sound alarming, but space is vast, and cosmic encounters unfold on timescales almost incomprehensible to human minds. For decades, astronomers wondered about the future of this approach. Would the two galaxies collide, or would they pass like ships in the night? The answer required measuring not just how fast Andromeda approaches, but also its sideways motion across the sky, an incredibly difficult observation to make across such vast distances. In 2012, astronomers using the Hubble Space Telescope measured Andromeda's sideways motion and concluded the galaxies would collide in approximately 4 billion years. NASA science. The announcement captured imaginations worldwide. The Milky Way seemed destined for a head-on cosmic collision that would reshape both galaxies beyond recognition. Computer simulations painted a dramatic picture of this future encounter. The two galaxies would take an additional 2 billion years after first contact to completely merge under the tug of gravity. NASA science, eventually forming a single elliptical galaxy, no longer spiral, but a vast football-shaped swarm of stars. Yet recent research has complicated this story. In 2025, astronomers reconsidered the prediction using the latest data from both Hubble and the Gaia Space Telescope, accounting for the gravitational effects of other galaxies in our local group nature. After running 100,000 simulations stretching 10 billion years into the future, they concluded there is only about a 50% chance of collision within that timeframe. NASA science. The Large Magellanic Cloud, a satellite galaxy of the Milky Way, pulls our galaxy off the orbital plane and away from Andromeda, making collision less likely. NASA science. Meanwhile, Andromeda's satellite galaxy M33, the Triangulum Galaxy, pulls the Milky Way slightly more toward Andromeda. NASA science. These competing gravitational tugs create uncertainty. The galaxies might merge as predicted, or they might pass by each other, orbiting at a distance before eventually coming together far in the future, or perhaps never merging at all. Chapter 8. The Distant Future. Even if the collision happens, what would it mean? The popular imagination conjures images of stars crashing together like cars in a pileup. But space is mostly empty. While Andromeda contains about 1 trillion stars and the Milky Way about 300 billion, the chance of even two stars colliding is negligible because of the huge distances between them. Wikipedia. The nearest star to Earth after the Sun is Proxima Centauri, about 4.2 light-years away. Wikipedia. A distance so vast that if the Sun were a ping-pong ball, Proxima Centauri would be a P located 1,100 kilometers distant. When galaxies merge, most stars pass through the encounter unscathed, though their orbits are dramatically altered. The Sun will likely be flung into a new region of the merged galaxy. NASA science, perhaps relocated to a completely different neighborhood of stars. The night sky from Earth, if our planet still existed, would be transformed beyond recognition. But Earth's fate is sealed regardless of what Andromeda does. By the time of any potential collision, Earth's surface will have already become far too hot for liquid water to exist due to the gradually increasing luminosity of the Sun. Wikipedia. This is expected to happen in about 500 million to 1.5 billion years, long before any galactic merger. Our Sun, like all stars, grows brighter as it ages, and eventually it will transform Earth into a scorched, lifeless world before expanding into a red giant that may consume the planet entirely. If the merger does occur, the collision would trigger intense star formation, as gas clouds from both galaxies crash together and compress Astronomy.com. The supermassive black holes at each galaxy's center would eventually spiral toward each other, converging near the center of the newly formed galaxy over a period that may take millions of years. Astronomy.com. The resulting cosmic fireworks, supernovae, stellar nurseries, radiation from the combined black hole, would illuminate the merger for billions of light years. If collision occurs, it would most likely happen in 7 to 8 billion years, and both galaxies would be destroyed, leaving behind a spheroidal pile of stars known as an elliptical galaxy. Durham University. But perhaps the most comforting possibility is the near-miss scenario. If the galaxies successfully swerve around one another, that's good news for future worlds, as a merger would prevent gas from cooling and forming new stars and planets. National Geographic. A galaxy that avoids collision maintains its spiral structure and continues birthing stars. And with stars come planets, and with planets, perhaps life. The future remains beautifully uncertain, written in gravitational equations too complex for perfect prediction. Epilogue. Our place in the river. On a clear, moonless night, away from city lights, the Milky Way reveals itself in all its glory. That band of light crossing the sky, once thought to be spilled milk from the breast of Hera, once imagined as a celestial road, is your home seen from within. You are standing on a planet orbiting a star that is itself orbiting the center of a galaxy containing hundreds of billions of stars. You are part of a structure that began forming 14 billion years ago, that survived collisions and mergers, that transformed chaos into the elegant spiral wheeling through space. The atoms in your body were forged in stars that lived and died before the Sun was born, scattered by supernovae, gathered into clouds, collapsed into our solar system, and assembled into you. The Milky Way is not just a place. It is a history, a story written in starlight and gravity, in gas and dust and the patient work of time. It is a middle-aged galaxy in a universe of galaxies, neither the largest nor the smallest, neither the most active nor the quietest, but simply one among countless billions. Yet it is ours. It is home to every human who has ever lived, every story ever told, every love and loss and triumph and tragedy in the human experience. We are all of us, children of the Milky Way, made of stardust, temporary arrangements of matter that have become conscious and learned to look up at the galaxy that made us and recognize our place in its vastness. The ancient Greeks saw spilled milk. We see something far more profound, a galaxy in its prime, peacefully turning through the universe, creating stars that create planets that create, sometimes, in rare and precious places, life itself. We see our origin and our context, the stage upon which the entire human drama has unfolded. And someday, billions of years from now, whether through merger or near miss, the Milky Way's chapter will close and a new one will begin. But tonight, this moment, the galaxy stretches above us, a river of light, a spiral of stars, a home beyond comprehension and yet somehow, impossibly, intimately ours. Look up. You are seeing yourself from the inside, a part of the galaxy observing itself, stardust contemplating its own origin. In that moment of recognition lies something transcendent, the universe becoming aware of its own beauty. The Milky Way wheels onward through the cosmic night, and we wheel with it, temporary passengers on an eternal journey, brief sparks of consciousness in a galaxy that will shine long after we are gone, yet which would be diminished without us, for we are the eyes through which it sees itself, the minds through which it knows its own story. We are the Milky Way, and the Milky Way is us, and in that unity lies the deepest meaning we may ever find beneath the stars.